It's time to take a look at section 5.9. We're going to be working with complex numbers and performing some operations. So notice our target for today is perform operations with complex numbers. So all we're going to do in this section is manipulate complex numbers in different ways. It's important to understand that even though we are just manipulating, there's some underlying math that's going on here that we're just going to have to accept as true and move on. So let's take a look. This section is no calculator. Let's first express the given number in terms of I. Just as a recall, these three things in the let's go are going to be used today in our lesson. So we can, of course, break this up into root 18 and root -1 with the -1 in front. The 18 goes to the 9 and the 2. Then you have the -1 underneath. And the last time I checked, you should be having -3i root 2. Notice any plus or minus there? Holla, I don't think so, because you are just expressing the given number in terms of I. Complex conjugate. First of all, is this written in A plus BI form? Is it? What do you think? No, it's not. That's a problem. What we need to do there is just make sure we rewrite it real quick just to feel all warm and fuzzy on the inside. And our complex conjugate, remember, you change the sign on the imaginary portion. Okay? And finally, to determine the product of these two numbers, you have one whole plus an irrational, or we could even say natural. Look at me and my bad self go. You have to FOIL. Okay? Those things are all going to come to play today, and I hope you came to play because we're going big, baby. All right, let's take a look. The complex plane. So the first part of our first target is to graph in the complex plane. You're like, what is happening right now, people? Calm it down. Like I said, there's underlying math here that, as you move up the ladder, you're going to get to. We're just manipulating and working with them here. So basically, the complex plane is the plane that has the imaginary axis and then the real axis. The real axis lying along what we would consider the x-axis, and then the imaginary, what we would consider like the y. I'm going to write like because it's not the same thing, friends. It's a totally different axis. You're talking real and imaginary. So in order to plot, really all you got to do is look at the real part. This goes along the, and I'll put it in quotes, the x, and then the imaginary part. This goes along the y, which, as you can see, you have the axes labeled. So you're going to go over 2 on the real axis and then down 3i. There's your dot for A. Look at me getting to play with color. What should I go with next? So many choices. Let's go lime green. For B, you're going to go and work back 1 on the real axis and then up 4i on the imaginary. Oh, that's so pretty. Oh my, this is so much fun. Take a look at C. Go over 4 on the real axis, and then that's 1i, so go up 1. Put a dot there, C. Finally, I don't know, is there any tricky ones? Let's just do one more. Let's go yellow, so you can't see it. I'll graph the last one in white. -1i, well, you go 0 on the real axis, so I'm not going to move horizontally at all, and then I just go down right here. That would be D. Graphing in white, 3 plus 0i is just going to be over 3 and then up none. Yeah, I just graphed in white. You can't see my answer. Get on my level. Okay, that's the first part. Good job. Graphed a complex number on the complex plane with labels. I'm proud of you. Take a look at the second part here, my friends. The absolute value of a complex number. Okay, this should not come as a shock because the idea of the absolute value function is that it provides you a distance. So, when working with the absolute value of a complex number, it is the distance, oh, I'm still in white, this is so exciting. It is the distance from the origin to the point in the complex plane. So basically, how do we find that distance? You have a right triangle. The last time I checked, you might want to take a hot, fresh look at the Pythagorean theorem, right? C squared equals, whoopsie, fumble recovered, a squared plus b squared. You would solve for your c in this case by taking the square root. Look at that. Isn't that cray-cray? There it is right there. Okay, so basically all you got to do is look for the complex number given to calculate the absolute value. Well, here's your A, here's your B. Oh my goodness, it is so nice when math works and letters line up and things make sense. So your A is 3, your B is 5. You're not going to be dealing with the idea of I, and there's several reasons for that. It actually would just kind of cancel out when you're working with the squaring and whatnot. We'll talk about that later. The sign's a little off, okay, but you actually just are focused on the numeric value there. So all you have to do is 3 squared plus 5 squared. Whoa, 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 retraction. Saved. Nice. And you take the square root of that. So you use the Pythagorean theorem. Last time I checked, that's root 34. And that is in simplest form. That's the absolute value of that given complex number, the distance it is from the origin, the distance away from the origin. Okay? 13, well, you're going to die laughing. A equals negative 13, B equals 0. So if you apply the idea of the square root of negative 13 squared, use parentheses there, just should mention that, plus 0 squared, last time I checked, that would just be 13. Okay? Similarly here, what do you think you get in number 3? Oh, wait. Got all the time in the world, baby. I'm just saying. It's 7. Good job. Holla, nailed it. All right. Take a look at the next video, my friends, and you'll get to see how to add and subtract complex numbers, examples 3, 4, oh my goodness, and 5 and 6. There's so much good stuff still remaining, so stay tuned. 1, 2, maybe 3 more videos to go depending on my mood. All right, nice work.